just a couple of minutes just to talk about my research that has been going on around integrated sensing and communication. So I work around different topics. So this is one of the topics that I really enjoy working on. And it's also like kind of timely topic in recent times. Yeah, I mean, I've also given like a couple of links and stuff. So if you are ever interested to sort of collaborate or sort of check my research, so these are some of the links, and you can always contact me via email and even WhatsApp if you have my WhatsApp. So basically, what we see is that what have been the expectations for 5G, right, from 5G that has been actually doing recently, is that we were always working out around sort of a triangular frame. So we have this enhanced mobile broadband, ultra reliable low latency communication, or let's say massive machine type communication. So as you can see here, we always had some sort of triangular framework that we worked around. In 5G Advanced, we expect the same, but with more advanced version of what 5G was offering. Right? And we do see that compared to the previous standards, the growth of 5G subscriptions is quite high. Higher than the relatively higher than 4G or 4G LTE or something that we were dealing with earlier, right? So that's what the industry reports actually suggest us. And you also see that the world population coverage for 5G in the next couple of years, by 2028, 2029, is expected to raise quite high. So the idea is that we should keep working on keep improving 5G, because again, whatever the promises were made, they are not fully fulfilled, let's say that way. But again, we should also expect some advancement in 5G Advanced as well, 5G Advanced standards, 5G Advanced based services, and so on. So this is about 5G, but when 6G comes into picture, so again, we need to be very careful is what we are sort of agreeing on based on what is the kind of consensus we have around us. So you see that the picture changes a bit. So you basically have some additions. So you are working on the triangular framework, so you expand on that one, but then you also add some enhanced capabilities. So you may have seen this figure so many times in all the talks and everywhere. Everyone is presenting that. So just to give an idea that we are working towards multifunctional systems. So we are trying to add, additional sort of architecture, additional sort of systems, additional sort of capabilities to your existing infrastructure that you have, right? So you're adding sensing on board. If you have your communication device, your mobile device, it is also able to do a sensing sort of operation, right? So your mobile device, if I'm walking around, it might be able to sense around me, like sort of environment monitoring, right? If I'm in my car or something like a driverless car, maybe I need sensing a lot, right? So the idea is that whatever your communication infrastructure is there, you're adding up some additional sort of activity. So in terms of this, it's sensing. Then you have integrated AI in communication. So the idea is that how to use AI for communication, right? So how to apply, let's say, all these machine learning, all these automated approaches for communication, and vice versa. So how to use communication fundamentals and principles for AI as well, like in over-the-air computation, right? So we also need to check that as well, that how to integrate different fields together with our communication. So I would be correct in saying that 6G is not just communication, it's not just connectivity, right? It's beyond that, because you're adding up, enhanced capabilities and so on. Then you have ubiquitous connectivity as well. So basically, this is working on non-terrestrial networks and so on. Again, it's not a very new idea. I mean, it has been talks like for decades, but we see that in 6G it's really coming into picture, into implementation stage. So you see that many industry stakeholders are taking a lot of interest into non-terrestrial network-based connectivity, not really replacing the ground network, but actually complementing. So that's a very important point. That is an integration of your terrestrial network with your non-terrestrial. And then you can come up with like multiple sort of applications and use cases. You see like here, we have tried to list as many as possible: smart cities, autonomous driving, remote surgery, smart homes, using AI ML for comms, of course, swarm of UAV, satellite communication, so many of these that you can think of when it comes to 6G. And we also need to see that how we are progressing standards as well. So basically, what we see is that we are going hand in hand, we are going parallel. So whatever we are sort of aiming through our 6G framework or the IMT 2030 framework, that is also reflected in standards as well. So you see how we have actually evolved from, the most previous generation that we started with very basic sort of analog and digital communications. Now we moved towards, complementing our infrastructure with, backhaul networks, with, network slicing, network management in an intelligent way, and then also trying to push machine learning, AI, and so on. So the idea here is that when you look at release 70 that was completed, so you have the non-trusted networks also coming into picture, right? And then you have many of these technologies that we talk about in our 6G framework. They have been included in release 17 and also release 18 and 19. So the idea here is that we are going in parallel. So in standards development and what we decided with our 6G infrastructure to be able to do is going in parallel. So that's the idea of projecting this slide. And again, you're going from the triangular framework to this sort of hexagonal looking framework. So if you specifically talk about release 18 and 19, so many of these are being explored, as I was mentioning earlier. So some of these I've listed here. So especially, let's say release 19, so that, it has been, some early study items have been defined already now into release 19 of 3GPP. So you have massive MIMO to work around next generation MIMO techniques, right? And high mobility scenarios is very important because if you deal with, let's say, stationary sort of scenarios, it's not very practical, right? Because in practical networks, we need very high mobility, right? So your drones are moving, your flying platforms are moving, your satellites are on rotation, then you have your, you want to provide this connectivity when they're moving vehicles, let's say, so right? So the idea is that you also want to deal with high mobility scenarios as well. So this has been included in this 19 of PG. Then AI, machine learning as well, of course, this has been, a topic of interest for many years now. And then especially checking the applications for next generation radio access networks. So that is also one of the key points. Then extended reality, virtual reality, all this also comes into, all these 6G based connectivity. Again, it's a combination of different things, connectivity, computing. And then my favorite topic is actually energy efficiency. So basically to come out with very energy efficient solutions. So if you may recall that our, initial 5G based applications or use cases, they were not so energy efficient, even the devices themselves, right? So a lot of power consuming components we were using. Industry people might know this very well. So the idea is to actually work around these energy efficient solutions as well, right? When we are going forward to 6G. And also it, aligns with all these government strategies and, COP meetings and so on to lead towards net zero, right? So on system level, on network level, we should come up with energy efficient solutions. And then non-trusted networks, we continued, since 2017, that is there. And the addition, one of the stars of the sort of GPP release 19, sensing communication core design, right? So basically, you have the addition of integrated sensing communication, if you want to call it that way. And there have been several early study items around this idea, right? So there have been, SA1, SA6. You can check. I mean, if you are really into standards. So they have tried to come up with two main aspects of it. First of all is communication assisted sensing. So you have your sensing equipment and communication is just complementing. It's an additional feature of that. Or you can have a sensing assisted communication. So you have your communication device, but sensing is actually complementing that, assisting that. So they started with something very basic, it's not very advanced, right? Even though in theory you can see some advanced things, they're trying to play around with trade-offs and so on. But industry people or standards guys, they are more practical, so they started with something very sort of initial ideas. And there have been 32 industry use cases around. So I will discuss in next slide as well. So if you also see, I mean, again, this is like an information that you can find everywhere. So you see that the global revenue is increasing for ISAC, and we're expecting that it will keep increasing, right? And then you also see that different regions also have some priorities. So ISAC is one of the priority areas as well, especially for North America in general. Several key enablers, several challenges. So again, I mean, there are several of them. So I've listed as many as I could. And you can also see in 3GPP release 19 how we are progressing. So we started with something, some feasibility study ideas, and then service requirements that we may need. So the first release 19 SA1 that was defined was discussing about these sort of topics. And then we also moved on to application-based things. And then in brand one group, we see about channel modeling, right? So this is also very important, that because it is a problem in a way that because we are used to this communication sort of channel modeling, right? Where we know these electromagnetic characteristics of the environment, let's say when we are using a channel. But when sensing comes on board, it becomes a bit complicated, it becomes different, right? Because you have additional capabilities to take care of. So this is something very important, that how to model your channel or how to estimate your channel when you're using a dual function signal, when your signal carries the information of sensing and communication both. So it becomes very important. And as I was talking about, particular use cases for functionality requirements, so several of these: smart home, smart healthcare, factories, indoors, AGV scenarios, robotic scenarios, and I don't know what not. I mean, many of these, they have been mentioned, public safety use cases as well. So they are all discussed into these sort of 3GPP release 19 when they define the sort of use cases here. And we also did some podcasts very recently. So we do under ComSoc. So we talked about some of these ideas, some of these trends as well about that. So I think I will go quicker from here. So just one thing to mention here is that we also should see what kind of frequency spectrum we are going to use when we deploy ISAC. So as you see for 6G, looks like that centimeter wave, let's say low to mid band sort of spectrum, is like key enabling spectrum, because the idea is that we do not want to move too far away from what we are already using. Right? So we are using our sub 6 gigahertz frequencies. So we want to keep our lives easier and use something closer to the frequency. So 7, 8, 9, 10, 11 gigahertz sort of frequencies look like the sort of possible candidates when we try to implement 6G or deploy 6G based services. And we also want to explore sub-terahertz bands as well, that in some geographic locations can be more like a complementary spectrum. It's not that we need sub-terahertz everywhere. Again, you need to see that for high frequency spectrum, you have several problems, right? Atlas effects, blockage effects, and so on. So we need to take those into account. But anyway, it doesn't stop us to explore high frequency bands. And you can see multiple applications. So I mean, we are dealing with ISAC. This topic of my talk is ISAC. So basically, you see that we also try to do some experimentation around, at these different frequencies, centimeter waves, sub-terahertz, and so on, and some experimentation papers using, ISAC technology. And just some literature around here. So I will try to wrap up quick. It's just trying to show that how you can.
Sorry.
Hello. Is it someone online or? Yeah, so I mean, the idea is that you can either use, let's say, sensing and communication under one network, so they can be coexisting. So let's say we are sitting in this room. So I might have a communication device with me and maybe a sensing equipment at the corner of the room. So they might be coordinating with each other. So it's like a coexistence scenario. Or I can have my mobile device. It can be a sensor itself as well. So this is like a sort of dual function signal that we say, right? I mean, that is able to do both sensing and communication. Right? So it's a joint sensing communication. I mean, the terminology is again not so much defined, but that's what we say: coexistence scenario or joint scenario for these. And we also did a book. So I like to advertise, I mean, what we have been progressing in the area. So, I mean, we have 50 plus contributors from all around the globe who are working on this ISAC technology and with the key enabling technologies and so on. So I had a lot of work to do here, but I really thank the contributors. I mean, they made it possible. I was just the sort of channel to make it happen. And I did this book very recently, and it is out there. So you're welcome to order the book already. So by December, you should have it in your homes. If you need a digital copy, please let me know personally. I will send you. So I shouldn't say it now, but yeah, let me know. So we discussed about many of these things, meta surfaces and AI machine learning for ISAC, trying to explore ISAC at different frequencies, terahertz, millimeter wave, and so on. And we also have, and the good thing is that we also have several industry people as well. This one, they try to, show what has been happening in terms of implementation. So it's a good release, it's latest. So that was the idea to come up with something very latest. And so it does that. So I will skip this. I mean, again, it can be too technical if I go here. It's just that we can come up with some energy efficient architectures of ISAC, and we can also come up with some sort of spectrally efficient architectures as well. So given the links to papers, again, I don't want to take time from other speaker slots, so I will try to wrap this up quick. Different use cases as well. So as I was mentioning earlier, around those 32 use cases, the industry use cases, we can talk about smart healthcare, how to use it for localization, positioning, right? Maybe simultaneous imaging, mapping, or localization together. We require centimeter level sort of accuracy. So for this one, we need good sensing capabilities for our communication devices. So several of these things, and also one of the topics that is, we are working on recently is 6G for robotics. So we try to explore ISAC for robotics as well. So this is quite a niche topic, robotics to explore. So in one of the papers we did recently, we try to see how we can use ISAC for robotics applications as well with our industry colleagues. So we need to keep in mind is that there are many challenges here, technical and non-technical both. So security is the biggest concern, privacy is the biggest concern at the moment. So it's both technical and non-technical challenge, right? So when you're trying to sense your environment, monitor your environment, right, you cannot be sensing everything around you. So this is a very important thing that it has to be regulated. There has to be some sort of compliance sort of thing, regulating the thing. So that is very important, right? So these challenges are there, and some other technical challenges, about how to model the channel, how to design the waveform efficiently. So that is also very important. How to handle this, data that is coming out of this, joint system that we have. And again, regulatory considerations as well that we consider that we explain. I will not go into details of this as well, but the idea is that you can also combine, ISAC with, some sort of intelligent meta surfaces techniques as well. So where for transmission you are using, let's say, your intelligent meta surfaces, or breeze, holographic line, or whatever you're coming up, stack meta surfaces. Like Marco will also talk about stack meta surfaces. So you can combine these technologies with ISAC as well. And then you can also come up with some greater good applications. So this is also one of my favorite slides, is to say that, when you have different techniques on board, whether it's AI, you're using on, let's say, for resource allocation or something on satellites, you can combine this with, your non-terrestrial network. So you have drones, satellites, everything sort of trying to send your dual function signals. So you have ISAC combined with NTN, with AI, and so on. And also, you can reflect the signal using all these meta surfaces. They can be on a stationary object, on another roof of a building, on a vehicle, maybe it's a moving vehicle. You can also have it there. So the idea is that you can, do some greater good applications, like in public safety. So where you need to detect objects, right? You need to track some things, perhaps, because the link that was actually working, that was actually serving that particular area, is broken because of the disaster, unfortunately, right? So in those scenarios, you can send in your drones, your small mobility. You can use satellite connectivity directly, right? But the idea is that there is a dual function signal. It's able to do both sensing and communication. It's a very complex idea, but still there is some feasibility. So the idea is that you can come out with different sort of greater good applications, like for public safety, disaster management, and so on as well, combining all these things. Again, we discuss about these ideas in several papers, books, maybe, I don't know, several of things that we discussed. But I wanted to project that as well, that these are important technologies to work around, but we need to remember is that there are many challenges that we need to encounter as well when we are talking about such scenarios. And you can do more advancements as well. So with Chung, I think we did a very recent paper as well on using, let's say, for quantum enhanced DRL approaches for ISAC. So you combine everything, NTN, ISAC, meta surfaces, and then you also put in some sort of machine learning. So this is also a very good read. I mean, recently got published in JSAC as well. And we also are working around how we can improve, let's say, not just using DRL, but maybe quantum DRL, or maybe federated learning, or quantum federated learning, right, to improve this system. So that is also we are trying to explore very recently in some of our papers. Different conclusions, again, I will not read. So just one key point is that the future looks quite bright when it comes for ISAC to be used for 6G, to make 6G a reality. Because we need to know that we have aimed too much for 6G. So again, we don't want to repeat the same things as we did with 5G. So that's why we should be careful in using that. ISAC should be for 6G and beyond. So we may have some initial things for 6G, but we expect that even for beyond 6G, we expect ISAC to still be there. And again, there are many challenges there. And this might be of interest to you. So we have done several of these podcasts with lots of our colleagues who are also present here. So you can also have a quick look. So this is one of my, let's say, hobbies, maybe in free time with me too. And also thanks to all the colleagues who find time to talk about different technologies and so on. So thank you. If you have any questions.